So this problem 36 is a conservation of momentum problem, and it's an elastic collision. Somebody in the other class asked me, how do you know the difference between when it's elastic and when it's inelastic? If it's inelastic, they'll use the words like the objects after collision stick together, or one becomes embedded in the other. That would mean it's inelastic. If it doesn't say that, and if they give you the velocity of one object after the collision and ask you for the other one, then they have two different velocities after collision, and we assume that to be an elastic collision. And we always assume the collision to be a perfectly elastic collision, even though in real life, you're never going to get a perfectly elastic collision. So in this problem, what I would do is just list my facts. The one mistake that I see made is the sign, getting the sign wrong. So that's the one thing I want you to pay attention to when you're doing these momentum problems. So it says a plastic ball with a mass of 100 grams. Another thing, even though momentum, I said, is usually the units are kilogram meters per second, if you're doing a conservation of momentum problem, and if all of your masses are in grams, you can leave them in grams. You don't have to convert them to kilograms because the unit of mass will cancel out in the end. So M1 is 100 grams. It's moving with a speed of 25 meters per second. So I'm going to commit to that being my positive direction. So the first ball is going to the right at 25 meters per second. Then it says a second ball with a mass of 140. So if we have 140 grams mass, it's moving towards, now this is the key, it's moving towards the first ball with a speed of 10 meters per second. So since it's moving towards the first, what should I write down for my V2? Negative 10 meters per second. And those that don't get this right, that's the mistake that they're going to make, is they're not going to have the negative. There's not really a lot of places you can mess up on this problem. But that's the mistake, is people don't have that. And then it says, after collision, then it says the two balls collide. After the collision, the 100-gram ball, so also make sure you match up. The 100-gram ball is the first ball. The 140 is the second ball. So when they say, after the collision, the 100-gram ball has a velocity of 3 meters per second in its original direction. So that's going to be V1 prime, 3 meters per second in its original direction. Now, if it changed direction, I would make this number a negative, because it could have hit and bounced back. I'm saying that it hit and continued to move in the same direction. Again, I just made that up. I made that up as a number. So V2 prime is now our unknown. So if you have what I have on the board now, you would get 6 out of 10 points. So the problem is going to be worth 10 points, just like when we did straight line motion, we had so many points for the facts and then so many for writing the equation, rearranging. Well, there's more facts here than in straight line motion. Straight line motion, there's only 4 facts, so I was able to give you more points for just writing the equation and doing the algebra. Here, if I'm giving you 6 points for the facts, then just writing the equation is only going to be worth 1 point. And the relevant equation is the law of conservation of momentum. So M1V1 plus M2V2 equals M1V1 prime plus M2V2 prime. So that's a point. So now we're at 7 points. Now in the problem that I did yesterday, one of the objects wasn't moving before the collision. So I was able to cancel out a whole term. Notice here there are 4 terms. That's a term, that's a term, that's a term, and that's a term. In the problem that I did yesterday, this object wasn't even moving, so that I could cancel out. But in this, nothing here is 0. So everything stays. And if I want to solve for V2 prime, I need to move this term to the other side, and then I'll divide by M2. So when I'm done with the algebra, V2 prime is going to equal. So these two are already on the side opposite this. So I'm going to write those two first. So it's going to be M1 V1 plus M2 V2. Now this one has to go over there. So since it was positive on this side, it's going to be negative on that side. So it's going to be minus M1 v1 prime. And then we're going to divide by, because at this point we would have this term isolated, but I just want v2 prime, so I need to get rid of m2, so now I divide both sides by m2. And that's a point. So now we're at 8 points. We're rearranging the equation, and now the last 2 points is substituting and solving. So v2 prime is going to be m1 v1 plus m2 v2 minus m1 v1 prime, all divided by m2. So for m1, we have 100 grams. Goes there and there. M2 is 140 grams, so that's going to go there and there. And see how the reason why it didn't matter whether I had it in grams or kilograms is the grams will all be canceled out by the grams down here. And then V1 is 25 meters per second. V2 is negative 10, so if you forgot the negative, you won't get the right answer for this. And then V1 prime, again, the first object kept moving in the same direction. It just slowed down. So it's still positive, and that's 3 meters per second. Now, if I get a positive value here for V2 prime, what that means is that V2 actually did bounce back. Because to begin with, it's moving in that direction because of the negative. It's moving there. If I get a positive value for V2 prime, it means it hit and bounced that way. And that's exactly what I get, right? If you solve this, I think the answer was, what was it, like 5.71? Is that the answer? 5.71 meters per second. Any questions with that? So most of the problems, that's the work that you have to do for most of the problems. That's the conservation of momentum problem. It's an elastic collision. And, you know, anything here could be the unknown. I mean, even the mass could be the unknown, right? I mean, anything could be the unknown here. So you've got 6 variables. And if you know 5 of the 6, then you can solve for the 6. So that was 36.